guys, it's Mrs. Millison. All right, let's go over the Check Your Understanding on page 89. Okay, I went ahead and copied the page from the book. That way I can write all over it. Okay, first let's do a quick little review of what percentile means. Okay, so percentile is simply the proportion of data that is less than or equal to the observation you're concerned about. Okay, so the first question says, let me get my other copy right here. First question says, Mark receives a score report detailing his performance on a statewide test. On the math section, Mark earned a raw score of 39, which places him in the 68th percentile. So 68th percentile. Okay, this means what? Okay, so let's talk about that for a second. So here's Mark. You got 0 to 100%. So 68th percentile is right about here, okay, because these are all percents. So that means 68% of the other students scored less than or equal to Mark, okay? So 68% of the students scored less than or equal to Mark, okay? Which means this other 32% scored higher, okay? So 32% of students scored higher than Mark. Okay, so now we got an idea what it means. Let's look at the answers. I'll move this down a little bit. Mark did better than 39% of the students who took the test. No, he did better than 68%. Mark did worse than 39%. I'm not sure where 39, 39 is coming from his raw score. His raw score has nothing to do with the percentages. Mark did better than 68% of those who took the test. That makes sense. And then Mark did worse than 68. No, he did worse than 32%. And Mark got fewer than half of the questions correct. Who knows? We don't know that. So C makes the most sense. Mark did better than about 68% of the students who took the test. So C is definitely the answer, okay? So in questions like this, think about what it means before you start reading the answers. Sometimes when you read the answers, everything gets all jumbled up. If you write out what it means, it's easier to pick out your answer. Okay, all right, let's look at number 2. Miss Munson is concerned about how her daughter's height and weight compare with those of other girls of the same age. She uses an online calculator to determine that her daughter is at the 80th percentile, or 87th, oh, that looks terrible, 87th percentile for weight, and the 67th percentile for height, okay? Explain to Miss Munson what this means. All right, so let's think about this. Again, go from 0 to 100, so 87's up here, and then from 0 to 100, 67's about here. So her daughter weighs more than 87% of other girls her age. And her daughter's height, she's taller than 67% of other girls her height. So that's not bad. She's pretty much in the range of what her height and weight should be, okay? I'm short, so being taller is always a good thing, I guess. And her weight is within the 0 to 100%. So it's not like she's, or it's in a nice area around the middle. So it's not like she's underweight or overweight. Okay, so Miss Munson should have no concern about her daughter's height and weight. She's fine. Okay. All right. Number 3. Here we go. We got to read this graph. The graph displays a cumulative relative frequency of the lengths of phone calls made from the mathematics department office at Gabelow High last month. I don't know where that school is. So what we do is we have to read our cumulative relative frequency. Oh, it looks like I drew little dots on my thing. Okay, I copied this from my book. It looks like I wrote in my book. Don't write in your book. Okay, first let's talk about how you read a cumulative relative frequency. We create these by basically stacking up our histogram till all the bars equal 100%. So what this means here, since this is 100%, these are the cumulative percentages. These are the call lengths in minutes. So 100% of the calls are about, ooh, sorry, I just hit the tripod. Oops. Are about 42 minutes and less, okay? So no call was over 42 minutes, okay? And of course we have 0 calls that were 0 minutes. So how we read this, about what percent of calls lasted less than 30 minutes? We go to our minutes, here's 30 minutes. We go up till we hit our graph, and then we go across until we hit our percentage. So I guess around 65% it looks like. So approximately 65% of the calls lasted less than 30 minutes. Okay, because everything's going down. Now, that means that 35% lasted longer than 35 minutes. Or, sorry, 35% lasted longer than 30 minutes. So 35% of the calls lasted more than 30 minutes. So we can also make the statement that a 30-minute call is at the 65th percentile. Because again, 65% of the calls were less than or equal to 30 minutes. Okay? Good. And then the last one says estimate Q1, Q3, and the IQR. Okay, so remember, these are percentages. These are percentages, and quartiles are based off of percentages. They're based off of quarter percents. So the median, so our median is at the 50th percentile. It's smack dab in the middle. So if I go up here, let me do a different color. Okay, if I do my 50th percentile, there's my 50th percentile. Okay, and I would go over and hit the graph. But I really am interested in the Q1 and Q3. So of course the Q1 is the middle of the bottom half, so that's our 25th percentile. And Q3 is the half of the top, half of the top half, so that's the 75th percentile. So let's go to 25 and 75. So this is 30, so this I would guess is 25. Ooh, went a little uphill there. Hit the graph and come down. I don't know, what do you think? 13 minutes, looks pretty good. And this is your work, drawing on the graph. So now if we come up 60, 80, here's 70, so here's 75. So if I go across my graph and hit my graph and come down, I'd say, I don't know, 32 minutes maybe? Okay, so those are my estimates of the first and third quartile. So of course now we have that, we can do our interquartile range, of course, Q3 minus Q1. Oops, my cat fell off. So 32 minus 13 would give me 19 minutes. So 19 minutes is the interquartile range of this distribution of call lengths, okay? Okay, I think that's about it. I will see you all next time. Bye-bye.